Yellowstone isn't just a national park or a tourist attraction, it's one of the most dangerous geological places on the planet. Beneath its surface lies a massive magma system, far larger than anything we usually think of as a volcano. You don't see rivers of lava, you don't see a smoking crater, you don't see the classic volcano shape. Instead, there are geysers, hot springs, clouds of steam, and calm-looking landscapes. And that calmness is exactly what makes it misleading. Yellowstone is a supervolcano. A supervolcano isn't a poetic term. It's a scientific one used for volcanic systems capable of causing not just local disasters, but global climate changes. Their eruptions don't just destroy cities, they reshape the planet. The last time Yellowstone erupted was around 640,000 years ago. Back then, massive amounts of ash entered the atmosphere, sunlight weakened, temperatures dropped, and ecosystems began to shift. This phenomenon is known as a volcanic winter. The problem is that the world today is completely different from what it was back then. Modern civilization depends on agriculture, global supply chains, air travel, communication, and a stable climate. That's why the question, what would happen if Yellowstone woke up, isn't fantasy. It's a real scientific scenario that geologists actually study. Supervolcano eruptions don't happen suddenly like an explosion in a movie. They're not instant disasters. They're long processes that can develop over years or even decades. And the most dangerous part is that for most of that time, they barely look like anything is happening at all. First, the ground itself starts to change. In the Yellowstone area, the surface is constantly rising and sinking, sometimes by a few centimeters, sometimes by much more. This happens because magma moves closer to the surface, then pulls back, then rises again. These shifts can only be detected with satellites and high-precision sensors. A person standing there wouldn't feel anything. The next sign is earthquakes. Yellowstone already experiences thousands of small tremors every year. Most of them are so weak that people don't even notice them. But if the system becomes unstable, both the number and the strength of these quakes would start to increase. One of the most worrying signals is changes in the chemical composition of water and gases. Scientists monitor levels of sulfur, carbon dioxide, and other substances. A sudden spike in these gases can mean that magma is moving closer to the surface. And this is where the main question comes up. If all of this can be measured, does that mean we'll know about the disaster in advance? The answer is yes and no. We'll be able to tell that the system is becoming unstable. We'll be able to say that the risk of an eruption is increasing, but we won't be able to predict the exact moment. It could happen in a year, in 10 years, or in 100. When the pressure inside the magma system reaches a critical point, the Earth's crust begins to break apart. In the first minutes, there won't be any of the usual images of flowing lava. The most noticeable thing will be the sound, a low, constant rumble, not like an explosion, but like a massive machine starting up. It will be heard hundreds of kilometers away. People won't just hear it, they'll feel it through vibrations in the air and the ground. Almost immediately, a column of ash will start rising into the sky. Within hours, it will reach the upper layers of the atmosphere. Air travel over North America would become impossible, not because of panic, but for physical reasons. Volcanic ash destroys jet engines. It acts like sandpaper, literally grinding down metal surfaces. Planes simply wouldn't be able to fly in that kind of air. Within a few hours, ash would start falling across huge areas. First near the epicenter, in a thick, heavy layer, then farther and farther away. And this is one of the most underestimated factors. Volcanic ash isn't light dust. It's heavy, wet, and sticky. When it builds up, it becomes more like wet concrete. Roofs would start collapsing under the weight, especially in cities where buildings aren't designed for that kind of load. Power grids would fail. Communication lines would go down. Water would become unsafe to drink because filtration systems wouldn't be able to handle that amount of fine particles. But the most serious threat is breathing. Tiny ash particles go deep into the lungs. They don't just irritate the airways, they actually damage the tissue. Without proper filters and masks, people wouldn't be able to stay outside for long. The ash would reach the east coast of the United States, then Europe, then Asia. It would fall with different intensity in different places, but even a thin layer in the atmosphere would already start changing how sunlight behaves. The sun would look dimmer, and that's when temperatures would begin to shift. This wouldn't feel like a normal cold spell. It would feel like a slow change in the climate itself. Summers would get colder, nights would get longer, crops would start failing. This phenomenon is called a volcanic winter. It's important to understand this isn't an ice age in the classic sense. It's not permanent frost or massive glaciers. It's a disruption of the climate balance that the entire modern ecosystem is adapted to. Plants are the first to react to changes like this. They need sunlight, specific temperatures, and stable seasons. When light becomes diffused and summers turn cold, photosynthesis slows down. Crops begin to fail. Some plants stop growing altogether. The problem is that modern humanity doesn't live off stockpiles. It lives off constant food production. We don't store food for years. We grow it, transport it, sell it, and consume it in a continuous cycle. And that cycle only works when the climate is stable. First, harvests drop, then prices rise, then supply chains start breaking, then governments impose export limits, then conflicts begin. Human history shows this clearly. Food shortages are one of the strongest drivers of instability. Mass migrations, political crises, wars, and the collapse of states have often started with food problems. And that leads to the most important question in this entire story. Not what would happen, but can this actually happen at all? Short answer, yes. Honest answer, we don't know when. And those are two very different things. Yellowstone is an active system. It's not dormant, and it's not extinct. Beneath it lies a magma chamber where processes are constantly happening. Molten rock is moving, pressure is building up, gases are being released, and the surrounding rock is deforming. Scientists are monitoring all of this. There are thousands of sensors installed across the area. They track earthquakes, ground uplift and subsidence, temperature changes, water chemistry, gas levels, and electromagnetic anomalies. It's one of the most closely observed geological zones on Earth. The problem is that even with this level of monitoring, we still can't predict supervolcano eruptions with precision. Yellowstone can't be stopped. Not technologically, not physically, not even in theory. The magma system sits tens of kilometers underground. It's not a hollow space or a reservoir you can access. It's a zone of partially melted rock under enormous pressure. We simply don't know how to operate in conditions like that. The deepest hole humans have ever drilled is about 12 kilometers. That doesn't even come close to the magma zones. That's just the upper layer of the crust. Yellowstone wouldn't destroy the world. It would show how thin the layer of stability really is, the one everything else is built on. That's why it's frightening. Not because of the explosion, but because it reminds us of something simple. Control is temporary.